Hey, good afternoon, everyone. Good afternoon.
Good afternoon, Professor.
How are you?
Hello, Professor.
Good, Professor. How are you?
Good, good, good. All righty. The first thing, let me. Okay, what's going on? You're sharing your screen. Okay, nothing new. Chrome OS. Hmm. All right. So, uh, about your homework one. I've been working on it the whole weekend, and it's really, really, um, it's so labor intensive and time consuming job. So you'll get it back by the end of the day today. Okay, you'll get it back. But just rest assured, uh, I've been working so laboriously or so arduously. It's an arduous thing, really. It's very time consuming and very labor intensive. And the second thing is how many people are in the forum today? And I see nine people except myself. And how many are in the how many are in here in the collaborate? Yeah, the numbers match. Nine and nine, and one more person is joining. So good. All righty. So we have Matt. Why is it eight suddenly? So two people are kind of, dropping on and off. I think it's their internet connection. Um, so basically, um, Elizabeth left us. Two people left the session, but I believe it is the internet connection. So uh, this is already. We have 5 week thing. We have 5 week. Um, yeah, summer two is 5 weeks. So we have really, really. Uh, so it's until the 22nd. This is second week, third week, fourth week, and um, together the last week and the first 2 days. We started on 20th, so that makes it 5 weeks. Okay. Now, so we were this. So I believe um, we did. Um, we were talking about the multiple cash flow model last time. Just one of them, future value of annuities. Right now, since we are talking about, I don't know if I'm using the same copy, but yeah, it must be the same copy. Um, I feel so I feel so constrained when I gotta get a okay. I feel so constrained with this. Um, excuse me, Office 365 because um, uh, because I have to use this. I'm using a Chromebook because, well, I have another Windows laptop, but that one doesn't allow me to. Um, that one isn't touchscreen, so there's nothing I cannot. Um, so I gotta get a. Um, so here, so last time we talked about the future value of annuity, right? And we understand what annuity is. Um, it's a regular deposit or payment made at regular interval. They modify time value, compounding. How did I name the file? Yeah. So one of the future value of annuity is one example of multiple cash flow model, and multiple cash flow means, as I said, um, future value of annuity is just a right a subset. That means it's part of this set, right? Subset, because I don't want to go back to the definition of multiple cash flow model. I mean, uh, previously we did single cash flow model, and in a single cash flow model there was only single cash outflow and single cash inflow. I mean, if you had single cash outflow now, in the future there will be single cash inflow, and if you had single cash inflow now, you will have single cash outflow in the future. What does that mean? Some people always say, what, what does that mean in plain English? I mean, it's just logic, right? It's just logic, not, so suppose suppose you had a, cash outflow now. What does that mean? You made a deposit today, right? That's cash outflow. You save the money with the bank today. That's cash outflow. And 10 years later, you take out that money. So you will take out the future value. That's cash inflow, right? So, and if there's a cash outflow today, that means you made a deposit or you made a loan. In other words, you made a loan or you made a deposit, and in the future there will be a cash inflow, right? The borrower paid back, or withdrew the money. You withdraw the money from the bank 10 years later. Now, the opposite is there's a cash inflow today. What does that mean? You borrowed money. And 10 years later, in the future, there will be a cash outflow because you have to pay it back, right? So that's basically, a single cash flow because there was only a single cash inflow, single cash outflow, a single cash flow model. In multiple cash flow model, actually, annuity is just one of them. Another one can be, so one is annuity. So let me put it, I should put it this way, I think. In multiple cash flow model, annuity. And there's a free form. So annuity is quite structured, isn't it right? Annuity is very strictly structured. It has to be regular amount at regular interval. Otherwise, and the interest rate is, constant. Obviously, think about it. If you have an annuity account with a bank, that means, you're saving money and for certain goal, and they can give you a fixed interest because you will make a regular deposit of regular amount at regular interval. Otherwise, they cannot give you a fixed rate, right? On the other hand, some people, I mean, in general, you may make a deposit anytime you come by some money, right? That's usually the case. Uh, so you make a deposit of, $5,000 this year at the beginning of this year, and you make a deposit of, $2,000 at the beginning of 2 years from now. Now think about it. That's free form. If that's the case, example, timeline, time zero. Let's say 10 years later. This is time 10. 10 and 1. Let's say and here at the beginning you make $2,000 deposit. 2 years later, 3K deposit, and in year 5, at the beginning of year 5, you make 5K deposit. And then what's going to be the future value at the end of year 10? Now think about it. In this case, it's erratic or sporadic. The interval is sporadic. You're making deposits sporadically, and then it's not even regular amount. Dollar amount is not regular. It's irregular. So it's not annuity, right? So this is not the case of annuity, but it's free form. And then they cannot guarantee you fixed interest rate. It will depend on whatever is the prevailing market rate at the time. So all interest rates can be different. For example, at the beginning of year 1, in other words, time 0, at that point the interest rate may have been 5%. But then, in year 2, interest rate could have been 2%. And 5, interest rate can be, 3%. Of course, once you put the money and then the interest rate, you lock into that interest rate. So the first deposit, second deposit, third deposit will have all different interest rate. But then for the until year 10, then think about it. Then this is also a case of multiple cash flow because there's multiple cash outflow, right, from you. But at the end, there will be a single cash inflow. But anyway, there's multiple cash flow. That goes without saying. Now then, in this case, the future value will be, in this case, the future value 10 will be first 2K, then that's 5%, so 1.05 raised to 10 years, right? Then plus 3K times 1.02, and from year, that's when year 1, year 2, from you put it in year 2. So for remaining how many years? 8 years. So it's going to be raised to and then plus you put 5K in year 5, right? 3, 4, 5. So 5k, and then 1.03 raised to 5, right? So this is another type of multiple cash flow model, but there's nothing, we can exploit from here. In other words, mathematically, what I'm saying is there's nothing we can mathematically exploit from here because there's no, basically, there's no unifying rule here. But when we have, annuity, there is unifying rule or unifying conditions, right? Or um, first of all, it's uh, regular amount at regular interval. So there is, of course, future value of annuity, and then there is present value of annuity. There is future value of annuity. There's present value. So we already did, future value of annuity, which is, payment times 1 plus r raised to n minus 1 over r. Okay. Now, so we did the example last time, but our question is then how did you get to? I mean, I explained to you that future value future value of annuity is basically payment times 1 plus r raised to, first one will have will be, compounded n minus 1 times, second one n minus 2 times. Cannot write there. What do I do? Okay, maybe I can do what I can do is oops. No, 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 no. Right? And then basically, you go until, just the payment, because in the last period, in ordinary annuity, in the last period, you just, you don't earn any interest because at the last, end of the period, you just dip the money in there and take it out. So technically, can we call it, deposit? Yeah, technically we can call it deposit, but it's almost as if, you're, taking it out as soon as you dip it in. So, but anyway, that's why you don't earn any interest. But remember last time I explained to you, this is so tedious to have this long polynomial because oh, what's going on? And so a nice way of, condensing all the long polynomial is basically p and p times 1 plus r raised to n, where n runs from 0 to t minus 1. Remember, when we have, in our example, which is our, graduate school fund example, and in that example, you will need that money. You will need $60,000 to go to graduate school from 5 years from now. So you need that money, at the end of year five, 60K. So you make the deposit at the end of every month for 60 months, 60 deposits. But think about it, because first deposit will be made at the end of first month until the end of month 60. It will be um, there will be 59 compoundings going on, right? That's why t minus one, and the last deposit uh, zero. Last deposit zero. It doesn't get compounded at all, right? Because anything raised to zero, right, is just one, right? Anything raised to zero is one, so it will just become payment. But once again, I've been telling you, this is not of operational. This formula doesn't uh, it's not able to actual calculation. It's a nice way of expressing the idea in a very compact way and a condensed way, but it doesn't really make any, it doesn't help any calculation. So instead, that's why we needed this reduced form formula. Eventually, this formula is the one that's making the calculation possible, because the way it is, uh, you will have to write all 60 terms anyway, right? So this doesn't help. Yeah, I guess someone was typing in something there. Or was it a question to? Okay, you are having okay, yeah. I'm glad you are back, because yeah, I understand. Sometimes connection is really the headache. Um, I know. I've been having also. It can happen to anybody. Um, and one thing, because I don't think we are going back to the old system, because after once, I mean, even after the COVID, right? Uh, we're not going back to like in-person, face-to-face. I mean, to some extent there will be some still in-person classes, but the majority of the classes will be conducted online, because there's more people, more students actually who can now afford time to attend uh, school, right, online uh, uh, than before, because there are more a lot of classes are offered online, and there are a lot of and the schools don't miss out on that. Schools don't want to miss out on that, because it's a bigger market, right? Now the people who couldn't um, uh, afford time to attend conventional uh, classes can now attend, right? So the schools do not, schools have noticed. So the majority of the courses will be uh, online, and and to make the online class more um, effective, then obviously the first thing is the strong, high-speed internet, right? Otherwise, if there's a intermittent, connection, and bad connection or poor connection, that's going to be and another thing is, all, all the computers. I used to have a touchscreen computer, Windows-based touchscreen computer, uh, and but that one was kind of slow. I mean, the RAM had relatively a small RAM, and so I need actually a high capacity, high RAM capacity, high CPU, very fast computer with with touch screen capability. And um, these days, it seems like touch screen computers are like you can't find any good touch screen computers under $1,000. I'm gonna have to still look for it. Until then, I will have to rely on this Chromebook, which is not very ideal either, but at least it's a touch screen. I will also uh, I will also try to explore it on my tablet, but then on the tablet again, it's still the same thing. I will have to use Excel through Office 365. So anyway, whatever so whatever it whatever it's gonna take, I'll have to. So anyway, the point is, I was talking about. So our question is, so how did we arrive at this formula? Okay, some of you may not be totally uninterested. I don't care. It's already a handful. It's already a handful to even to memorize that formula. Again, if possible, I want you to understand the steps of derivation. So if you master the steps of derivation, or the mathematically, in other words, why it came to this, then you don't have to memorize anything, right? But but let me. Okay, I guess I will talk about that later because um, we got a lot of things to do, and our time is very thin. So I would just move on to the next problem, next example. But we'll come back to the derivation, right? Steps of derivation. In other words, from why, how did it come to this? I'm gonna get to that later. So we're gonna move on to our next. Okay, so back here. So our next question is, we know, knowing that this is future value of annuity formula, right? And we tried 3-4 different strategies last time. Why? Because saving $800 every month, didn't satisfy our goal. Remember that? If the future value of annuity is just 55,816. So we're about still $4,000 short from our target future value. So we tried out, okay, we increase the payment or deposit, and I told you payment and deposit are two sides of the same coin. It's the same thing. So if we increase our deposit by $50, then we're close, but still $700 short. And if you find a bank that pays, change this, increase this, if the interest rate is 8%, again, in reality, it's not easy to find a bank that pays such superior interest rate, because I've been telling you, it's a very competitive. Banking is a very competitive industry, and even 0.1% makes a lot of difference, right? So even then, we're still falling short of our target. And then if we increase our timeline to 6 years, then we overshoot. We more than reach our goal. We even overshoot. Uh, now, but then is there a way? But again, we talked about also annuity due. Annuity due is the difference between the annuity due and ordinary annuity is just one more compounding. So I said reusability. We can recycle the previous result, and I'm talking about the reusability over and over because the homework and the homework one, a lot of you uh, a big oversight is that you don't realize the value of reusability. I mean, the reason we are doing this thing in Excel is so that we can reuse that model, reuse that program, reuse that algorithm, right? Reuse that coding, so that it can be replicated over and over without building it from the scratch all over again. But then a lot of people simply didn't appreciate that, or simply didn't realize the importance of the reusability and the problems that can be simply replicated. They built it all over again, and so it was one one problem. It's a pair of problem. For example, if it is LU10-3 and LU10-3A, they are basically pairs. Same pattern, just different numbers. Then if you build LU10-3, all you need to do is simply replicate 10-3, copy that 10-3 into 10-3A, and just change the numbers. That's reusability, recycle, right? Reusability. You don't need to, but a lot of people simply uh, didn't see the, uh, didn't see the that parallel between these pairs, and then they built a complete new and all disjointed. In other words, the model should be like what? It should be integrated in a single, right? A table like this, everything should be integrated in it, integrated. But then it was all disjointed, and the labels are all different again. Not under the same label, but all different. Uh, that's a disaster, right? The fact that you don't see the reusability and you don't understand the importance of that reusability, right? Then it's all back to the square one. You have to solve the new problem all over again, just like with pencil and paper. But that it will take time. Of course, it will take time. It was just the first homework, but until you get uh, the hang of it, it will take time. But anyway, again, this is also the reusability thing. So I told you the future value of annuity due, the difference between annuity due and ordinary annuity is just one more compounding. You see here, the simplified version, ordinary annuity, uh, the first deposit will get compounded only 4 times, although the timeline is 5 years. But annuity due gets compounded, first deposit gets compounded 5 times, right? So it's something like this. So every deposit gets one more compounding. So the difference is one more compounding. So we reuse this, recycle this, and just give it the result and give it one more compounding. Give it one more compounding, right? Okay. And then I can just drag it down. Ugh, this mouse is not. I can just drag it down and okay, voila. That's the next. Our question is then, oh no, I guess maybe if we increase our monthly deposit just a little, maybe we will hit our target because the difference is only about $700. So if you raise it to age 60, maybe we can do that. Let's try age 60. I mean, but then that's just trial and error method. Yeah, we hit, but we didn't exactly nail it. We overshot it by $2. We overshot it by $2. So one thing we can learn from this is, oh, so then it must be a number that is slightly less than 860. It must be a number that is slightly less than 860. But then how do we find it? Oh, we try, okay, then maybe, try 859. If it still overshoots, then it must be something like 858, somewhere between 858 and 859. But then that's called, trial and error method. Trial and error. Why? Because you try out different, possible numbers and hope to nail it. Um, this is this is very pathetic because sometimes this trial and error method may take forever. I mean, a lot of trials, and a lot of errors. But if you do it like that, then we are no better than like um, primitive times. Without trial and error, and that's also called reiterative method, reiterative, because you're reiterating the same process over and over. The computers can do this because computers can run like million calculations in a split second. So computers are basically, good for something like trial and error method. But uh, we can do better because we can exactly nail it. Why? So think of it this way. Um, look at the structure of this formula. Structure of this formula. It's already like z equals x times y format, right? Isn't it right? And what did I tell you? What have I been telling you over and over? I've been telling you that no matter how complex, an equation may seem, as long as you can identify this structure, z equals x times y structure, you can solve for anything. And if you see that our unknown, let's say this is our unknown because we want to nail the exact payment, right? We want to nail, we can nail the exact payment without trial and error method. We can solve for it. And payment is the unknown, which means x is the unknown. And when x is the unknown, when we know the z, that x is part of z equals x times y structure, we know what to do. We can solve for x, isn't it right? We can solve for x. That means, then x equals z over y. And then, therefore, then payment is then FBA, right? Divided by the thing in the bracket. Now you understand dividing by something is the same thing as multiplying by the reciprocal. And we know reciprocal is something raised to x, negative, right? Negative 1. Remember that? X to the negative 1. What is that? It's 1 over x. It's the reciprocal, right? Therefore, we can solve for payment by doing this. So if I write that out, I don't know if I can still write it. Okay, I can. Now we know it's going to be r over 1 plus r raised to n minus 1. Voila! And that's the formula for finding payment. Okay, that's the formula for finding payment. So then applying this formula, we're going to apply this formula, and here, so equal sign, is that equal sign? It looks like, yeah, equal sign. Okay, that's the future value, right? Future value of annuity divided by open parenthesis R. You might say, oh, there's no R there. Yes, I know. We can fill it up later. We'll first build the formula in there, and we can fill that later. We can fill that in later. 1 plus R raised to n minus 1. But here we need to put this in the parenthesis. So I think, we don't need to okay, here we are multiplying. I mean, now we are, I'm sorry, because we are multiplying by the reciprocal, then, just to, it's cumbersome to have so many parentheses, so we'll just, so many brackets, so we'll just simply get rid of, as long as we need to make sure that the Excel understands that this whole thing is, the denominator, right? So, put the parentheses around it. If you don't do that, Excel will only see 1 plus r raised to n, only that as the denominator, right? So then we don't want that. So hit enter, and then don't panic. You will say this because we have nothing here. But once we have, first R is 0.5% because it's the periodic rate, monthly rate. We'll do that. And then N is 60 because it's 5 times 12. Okay, once it's done, we got 859.97. Wow, how wonderful. What was our guess? Our guess was, it must be something slightly below 860. Why? Because when we tried A60, it overshot it just by $2. It overshot our target just by $2, 2.23. Isn't that right? So then, we could guess that it must be a number. It must be something that is slightly greater than slightly less than 860. Yeah, we nailed it. Slightly less than 860, and that nails our target, right? That hits our target. So everyone is okay up to this point. Everyone is good. Tell me, everyone is good? I only hear static. Everyone is following.
Yes.
Professor,
Okay.
I need to see that formula one more time. Thank you.
Okay. All righty. So I guess you mean this, right? Okay, good. And please take a screenshot if possible. Take a screenshot. So,
Okay, appreciate it. Thank
all
you.
right. All right, you're welcome. All righty. So, let me see. And then our next question is then again, just like in the single cash flow model, well, in the single cash flow model, what did we have? I mean, we could solve the equation for every variable, isn't it right? When we had uh, four variables, I mean, that means there's potentially there can be four unknowns, right? In the single cash flow model, right? Which is like this. So we can potentially have four unknowns, isn't it right? First, if this is the unknown, yeah. But if this is the unknown, we could solve for that. That's called discounting. The reverse process of compounding is called discounting. What if R is the unknown? We could solve for that. What if the N is the unknown? We could solve for that, right? Again, also in the annuity as well, the formula, although the formula is, this. Now, currently, this formula is basically telling you that future value of annuity is the unknown, then the rest of them are known, right? But again, this can be the unknown, and we just solve for that. What if, R is the unknown? What if the R is the unknown? How do we solve for it? What if the N is the unknown? Yeah, we can solve for every one of those cases. What if the N is the unknown? Yes. Again, four different, when there are four variables in the equation, you should be able to solve for, every unknown that, so what if N is the unknown? Now, interesting thing, first of all, so here's the this example. The same thing. Okay, we make 859.59. We make the deposit of, monthly deposit of 859.59 to reach our target of, 60K for 5 years. And so, okay, then what should be the interest rate? Now, the thing is, in annuity, in case of annuity, there's no unique single there's no unique single process or single formula to give you R, right? So in the old days, they used to they had to use the trial and error method. You have to take a guess, and it must be somewhere around. It should be around 5 and 7%, and you try out every possible, right? Every possible rate that satisfies this, equation. But then we have computer. We have the age. We are in the age of the computer. So we use for this one. We'll have to use Excel's built-in function. So we need to go to function, right? And then If it has been used already, it will show up in the commonly used or most frequently used. But if it doesn't show, we gotta go to the financial category, right? We'll have to find. And then we are looking for R, which is the rate. So what do? You scroll down until you find, uh, you go to, it's in alphabetical order. Oh, I cannot use a mouse here. I'll have to. So you scroll down until you get to R, but in R, there's already only one, just three variables, and the rate is the one we want. That's R, right? So we hit OK, and then it's gonna ask us what to put in. Down here it says rate. First, N period. That means N. You enter it, and then payment. You enter it, and then present value. There's no present value, so we don't have to enter it, but we need to put a comma, right? We need to put a comma. I mean, depending on the if you have, mostly if you have Windows computer, if you're using Microsoft Excel there's a dialog box, and you can just input the data in the dialog box. But this one doesn't allow me to do that. Because the reason for that comma is the placeholder. I mean, in that sequence, it has to be a present value. So if there's nothing, we should put a comma there, because if that sequence is disturbed, it's gonna give you it's not gonna work. So the next, so in future value of annuity, there is no present value. There is just the payment and the future value. Future value, this is our target future value. You enter that and put comma, and then type means it means ordinary annuity or annuity due. Okay, ordinary annuity or annuity due. And I've been telling you over and over, unless otherwise specified, the default is ordinary annuity. And in our scenario, it's also ordinary annuity, because you cannot make a deposit at time 0 because you haven't got paid. I mean, think about it. Our assumption is you got a part-time job, and from this part-time job, you're saving $800 every month, right? So you cannot put $800 before you get paid, right? So that's ordinary. If it is ordinary annuity, you don't put anything, or just put 0, right? You don't put anything or put 0, and then comma, right? Because you have to keep, and then close parenthesis. Now, if it is annuity due, you'll have to enter 1. If it is annuity due, you'll have to enter 1. Why? What does that 1 mean? I've been telling you, the difference between ordinary annuity and annuity due is one more compounding. One more compounding. That means, if you put 1 there, there's one more compounding. So that means it's annuity due. And here's one more thing you have to be careful about. When you enter the payment, you have to enter it as negative. Why? That means this is cash outflow. It doesn't really mean negative amount. It just means cash outflow, because you have to make distinction between cash outflow and cash inflow. Cash, in 5 years later, there's going to be this cash inflow of 60K. So we leave it as positive, but until then, every month there will be cash outflow from you at the end of every month, cash outflow of 859. So you make it negative, okay? And then you hit enter. There you go. It will give you the monthly rate, because we are dealing with monthly deposits, so the rate will come out as monthly. And then, but eventually we will need to convert it into an annual rate, because I've been telling you all the rates are expressed as annual. All the rates are expressed as annual. Therefore, and converting this into an annual rate is easy, because you simply multiply it by M. There you go, 6%. So it checks out. It checks out. Okay, everyone is good with that? Everyone is okay?
Yes, Professor.
Yes.
Okay, good, good. You got this. All right. Then next, what if the n is the unknown? What if n is the unknown? Okay. Now we have a formula for this, and then of course we need to use the natural law. The steps of derivation. Also, we have that formula here. I can show you. This is present value of annuity. We'll get to that later. Future value of annuity. Again, from this, we go through these, steps, and then take the natural law, and we come to, there you go, voila, right? So this is the formula. Of course, uh, we can use Excel's built-in function, but again, I don't want you to do that. I don't want you to. Excel's built-in function will just turn you into a data puncher, data entry personnel, without really knowing um, how to fix the error. If you're just punching in the data entry, data puncher, data entry personnel cannot fix the system when something goes wrong, right? Because they are just punching in the data. So, uh, if possible, always solve it by formula. So we already know the answer. It's gonna give us 60 months and 5 years, but let's see if this gives us exactly 60 months. So here it's what was the formula? Natural log, okay. It's natural log of future value over payment times 1 plus r, wasn't it? Yeah, times r plus 1, times r plus 1 times r. We're going to have that soon. It's not there yet. Plus 1 over natural log of 1 plus r. Of course, right now it's going to give you some error message. There you go. Because this one is missing. So as soon as, we know monthly rate, in this case, the periodic rate is that APR divided by M. There you go. The minute I, got that this automatically returns the correct answer, yeah, should be 60 months. And divide 60 months by 12, you get 5 years. So it all checks out. It all checks out. Okay? So everyone is good? Everyone is good up to this point? Okay.
Professor,
So
go back one
yeah,
more. Sorry. I just want to
yeah,
screenshot it.
yeah. So you see this now, right? You want to take the screenshot of this, right?
Yes.
Okay. So it's there now. It's there now.
Thank you.
You're welcome. So if there's no further questions, I think this is the right time to take a break. Okay, so it's about 4:03, 4:05. So we're gonna take a 10-minute and come back at like 4:15. Okay, all right, let's take a 10-minute. All right, we're back. We're back. Let me just quickly check. Let's see. We have, let me check the roll. We have 13 people currently in the hi Harold, saying hello to everyone, right? Now, so I see 13 people, and let me check how many are in the refresh. Okay, so it looks like I have wow, I have 16 people in the if I have 16 people, how come in the discussion board, how come I have only 13 here? 3 people are not here, but anyway, hopefully they are gonna join us shortly. And so, what was our? We got basically, okay, we have, yeah, we nailed it. So our next question. So if there's present value of future value of annuity, right? I also said that there is also present value of annuity. Okay. So what is present value of annuity? Now, if you think about it, annuities are all cash flows in the future, right? Annuities are all cash flows in the future because we're not interested in the cash flow in the past because it's all done. There's nothing we can, and um, we are basically, what we are interested in is the future cash flow because valuation of any asset depends on um, future cash flow. And whatever is going to happen in the future is yet undetermined, right? So um, that's why it's of interest to us, right? If it is already what has happened, then there's no need for. So here's an example of present value of annuity. Uh, so all cash flows are in the future. This one is, example of present value of ordinary annuity because all the payments are made at the end of each period. And this one is the uh, example of annuity due. Okay. And then I put, okay, I think this one rather than that one, this one is. So if you think about the 5-year timeline, this is ordinary annuity. Think about it. Just like the future value of annuity, the future value of annuity is what's the total, what's the sum of all those annuity payments that you are going to make or deposits that you're going to make in the future. What's the future value of that, right? Which is the sum of all those future values. Present value of annuities are, what is the present value of all those annuities as of now? So what's the sum of all those present values? So in this example, you're going to receive $5,000 at the end of each year. So there's going to be five payments of 5 payments. And if the interest rate is 10%, the first one will get discounted once. Second one gets discounted twice. Third one will get discounted 3 times, and so on. The fifth one will get discounted 5 times. That's quite, um, and then sum of all of that, right? You sum all of that. That's the present value of those annuities. Now, annuity due, the deposit or payment is made at the beginning of each period. So you discounted. The first one is not discounted at all because it's present value already. It's $1,000 already. Here, discount rate is 5%, but you see discounted by zero, right? 1.05 raised to zero. Anything raised to zero is 1, so it doesn't get discounted. The second one gets discounted once, right? Third one twice, fourth one 3 times, and the last one gets discounted 4 times, right? Because they are all made, at the beginning of each year. So if you understand this concept, then let's take a look at the example. One example. So I mean, let's start with that 5-year example because that's easier to understand. First payment gets discounted n times, right? I mean, actually, first one gets discounted only once. This is the last one. Nth payment will get discounted. So I think I better, either way. I better start with 1. The second one will get discounted squared, and we keep going like this, and until the last one, which is raised to n. And a condensed or compact way of expressing that is raised to t, where t or rather like this. More general notation is like, where n runs from 1 through t, right? In case of ordinary annuity, if it is annuity due, it will be like r raised to n, where n runs from 0 to t minus 1. Again, these expressions are only the concepts. They are not amenable to actual calculation. They are not operational. They are non-operational. They are just, nice way of. So we need a reduced form, right? We need the reduced form. So reduced form is r minus payment over r times 1 plus r raised to n. Okay, now they have several variant of this, but it's the same formula basically. You can think about it. You can factor out payment or payment over r. You can factor out because payment over r is the common factor. But although it can be simplified further, this I like to use it like this because this is the best variant or best.
Professor, you sound real bad right now.
I'm sorry. I don't. I sound what?
You're like breaking when you're talking.
Maybe I was moving
It
a
went
little
away
bit
now.
on. Okay, I'm better now. I'm better. Am I better now?
Kind of, sort of. I don't know if it's just me or other students are having the same problem.
How about other people? Is my voice
I can hear
breaking?
you, Professor.
Hmm?
I could hear you.
Okay. Okay. So I guess it was just to some people. Um, let's see. So as I said, although there are several versions of this, but I like this version because although it can be simplified more, right? It can be simplified further, but this is there's a good reason why this one uh, this one is actually this one breaks uh, this one breaks breaks apart, or this one breaks down the effect of uh, coupon payment and the effect of uh, 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 okay, either way, I think you will see. I will show you later. Now, so this is the reduced form. Of course, you can go further. I mean, think about it. You can factor out payment, and then this becomes 1 over r minus 1 over r times 1 plus r raised to n. And then you can find like common denominator, right? Common denominator. Actually, common denominator between the two is r. But what I'm saying is, you want to unify or combine. You want to unify the denominator. Then what you want is a GCM or LCM. The not what's least common multiplier. So the least common multiplier between the two is this, right? It's this. So basically, then if we can then unify or consolidate, combine the denominator for, think about it, for this to become this, 1 plus r raised to n must be multiplied to that. So if you multiply something to the denominator, you have to do the same to the numerator, right? That's the only way you can preserve the ratio. So I multiply 1 plus r raised to n to the numerator, and the right side, or the one in the right, it doesn't have to change at all, right? It doesn't have to change at all because it was already, the denominator was already r times 1 plus r raised to the n. So now, and then they still have different, versions, some, slightly tweaked versions of this. But, no matter what, this is the version I prefer. Okay, that's the version I prefer. Now, so to what kind of example, to what situation do we apply that? To what situation do we apply present value of annuity? Uh, here's that example. So suppose you won $10 million lottery. Of course, lottery is a very rare thing. I mean, winning the lottery is very rare. I mean, it's the probability of, but it doesn't happen uh, very often in your life. Probably never. But why do we use lottery? Is a bad. Practically not a very close to life example, but it's not just lottery. I mean, you will see structured settlement. What you call structured settlement. It's all just like this. Anyway, if you win the lottery, you have two payout options, right? All understand. It could be a lump sum cash or annuities, right? Uh, if you choose lump sum cash, you'll probably get about 60% of the uh, jackpot amount because you'll be taxed at the top tax rate, and the top tax rate is 39%. So that's almost 40%. So you'll get about 60%. So lump sum, if you choose lump sum, you'll receive either 6 million, or if you choose annuities, you'll get it over 29 years. You'll get it over 29 years in monthly payments. And 29 is almost 30 years, so we'll assume 30 years, right? So then, which one? So our mind-boggling question is, so then what do I choose? Do I go for lump sum, or do I go for uh, annuities? And whenever I ask this question, some students always say, I choose lump sum because, and the reason is why. If I ask, they always say, I don't know if I'm gonna be around anymore. For 30 years. I mean, if I choose, I don't know if I'm going to be around for the next 30 years. Well, if you have a very pessimistic outlook on your life, then I think you better take the lump sum. But everything is based on average life expectancy, and these days average life expectancy is most likely above 80 years. I mean, unless you lead a very unhealthy or reckless lifestyle, right? Uh, and if you take good care of yourself, eat correctly, or eat healthy, and exercise, and uh, uh, live a sensible lifestyle, not reckless lifestyle, then most likely you'll live up to that average life expectancy. But and being reasonable and sensible, and assuming that you're going to live at least for the next, if you guys are in your 20s, you'll live, probably for the next, 60 years. Uh, and my age, I may not have. I wish I had. I hope I have more than 30 years left. But if I, uh, but then, um, so based on that, reasonable average life expectancy, then our question is, how do we decide which one is better? Now, this is the question of apples and oranges, isn't it right? Apples and oranges, because you can't compare. Why? Because all these, our question is, you might think, oh, if I get 20K every month, so for the next 30 years is 360 months. And if you do this, you'll come to something like 7.2 million. And if you take lump sum is, 6 million. And some people might say, oh, I like this better. But then, first of all, you're forgetting, first of all, this is already present value. This is today's 6 million. This is today's 6 million. However, when does this exist? This doesn't exist in a single point in time, right? It's just a arithmetic sum. It's only an arithmetic sum of all those 20Ks, which are going to happen, from next month, right? So in other words, 7.2 million doesn't exist at any single point in time. It's spread across or spread over 360 months, right? So you can't directly compare these two. The only way you can compare them is because 6 million is already today's 6 million, right? Present value. You'll have to turn this into present value. So, okay, I discount 7.2 million no. Once again, 7.2 million is not future value. It doesn't exist anywhere. What you must discount is all those 360 of these 20Ks, right? So it's exactly like doing, you must do 360 of these. You must do discount like this for 360 of them. Now, obviously, that's not gonna be easy. I mean, it's a very tedious job. I mean, it's not difficult one, but tedious job if you do it, pencil and paper. Of course, we have Excel, so we can easily do that. But we have a formula. The formula is, again, we can handle that formula by, and we know the formula. And then if you find, so that's the present value of annuity formula, right? So we have present value of annuity formula, and we find the present value of all of those, payments, right? Okay, and then we can compare. In other words, when we have different fruits like apples and oranges, and in reality we cannot convert orange into apple, right? People like to say, it's an apple and orange question. You can't compare them directly. So if it is really apple and orange, you can't directly compare. But if it is, about, cash flow, you can do that. You can convert orange into apple or apple into orange. So we'll and second example. So again, that's annuity. Lottery is a very unrealistic example. If you think it is unrealistic, yeah, we have a more close to life, down to earth example. If you think about a loan, think about it. So far, we've been assuming if you got a loan, you're gonna pay back. Let's say you got a $1 million loan. Oh, then you think, oh, if I got, so I got the loan. So that's principal, right? Because you, or present value. So, and that's, you got what, let's say $1 million loan. Then if the interest rate is 10%, right, with APR 30 years time, you think, oh, so I need to know what's the future value because that's what I owe, right? So you'll think, oh, I'll do, that's single cash flow mind, right? You do, oh, 1 million times 1.1 raised to 30. No matter what that future value comes out to, the reality is, think about it. What kind of lender waits for you for 30 years to come up with that, full future value, right? Isn't that right? Have you ever seen a bank that waits 30 years for for you to pay back your mortgage? Huh? They don't give you 30 years. Once you got that $1 million mortgage or whatever, the payment starts already from the next month. Isn't it right? No lender waits, right? For the entire, so in reality, the loan is never a single cash flow model. Loan, loan is never a single cash flow model. Loan is always a present value of annuity problem because you are making a regular payment at regular interval for 30 years. So annuity, right? It's present value of annuity problem actually. Why? Because all those, why is it, is it not future value of annuity? Why is it present value of annuity problem? Because all those payments, the present value of all those payments must equal to $1 million. Present value of all those payments. In other words, uh, and each payment, right? Think about it. Each payment consists of, each payment is a sum of principal, part of principal, a small principal repaid, at interest, right? Each payment consists of interest and partial principal, and then they are not in consistent proportion all the time. They are not in consistent proportion through and through. The proportion will have to be, more in other words, if you think about it, it breaks down like this. So early on, so principal paid, interest. So time, first payment, second, third, as time goes on. Early on, you might think it is always constant. No, early on, the breakdown of the payment, is mostly, the composition is mostly like this. Early on, you pay, the payment consists mostly of interest, and then small, just a very little principal. And as time goes on, interest gets smaller and smaller and smaller, right? And principal gets bigger and bigger and bigger, right? Why? And it's only natural and logical. Why? As you make payments, right? Principal balance will go down. Principal balance will go down. Isn't that right? Principal balance will have to go down. And interest is based on the principal balance, and as the principal balance goes down, interest will have to go down as well. But your payment is always a constant number. Payment is a constant dollar amount. So when this portion gets smaller, this portion gets smaller, this portion will have to increase, right? When the interest, this portion goes down, this portion will have to go up, right? Makes sense? Now, so where was I? So in reality, so down to earth example is something like this, or closer to life. You consider buying a car, and the price of the car is $30,000. Of course, you may have 30K. You can afford probably to pay 30K out of your own pocket. But again, even if you can afford to pay lump sum, 30K in lump sum, that may not be a smart idea. If you consider if the financing cost is lower than the opportunity cost of that 30K, then financing it is a smart idea. So you consider financing $30,000 car for 5 years with 20% down payment. So what I'm saying is something like this. Now think about it. So even if you have 30K, if you pay if you use 30K to pay for the car, you don't have 30K anymore. But if you with this 30K, let's say you can you can find an investment opportunity that gives you 10% return a year. 10% return a year. Whereas if you borrow 30K, let's say, and then borrow, right? This is ROI, return on investment, right? And then the cost of financing, right? Cost of financing is, in other words, interest you have to pay is 5%. So then think about it. Simply, I mean, if this investment pays 10%, doesn't it make sense to borrow at 5%, right? And pay for the car, and then use your 30K to invest in this instrument, whatever it may be, and earn 10% a year. I mean, then this 10% return will more than pay for this 5%, and will still give you 5% left over. Isn't that right? If that is, a guaranteed deal, right? I mean, if you can lock into an investment that can pay you, that will pay you. I mean, this is guaranteed 10% return, right? But you can then this will definitely, in other words, you can effectively make 5% return by borrowing 30K, but investing 30K at the same time, right? It's going to be a self-financing deal, right? If this is the case. So that's why you don't pay 30K, even if you can afford to. You don't just pay 30K out of your own pocket, right? If this is the case. Now, so then in our example, actually in our example, what you borrowed is only 24K. Isn't that right? Because you made 20% down payment. So 20% down payment is your own equity. It came out of your own pocket. It's your own equity. Um, and then what is being borrowed is, or financed is 20K. I mean 24K. So then the next question is, you owe, of course, you owe 24K now, because usually when you buy a car, I don't know how many of you have ever, leased a vehicle or financed a vehicle. The thing is, uh, uh, at the dealership, they'll tell you, they say, oh, your monthly payment is $500, because you don't have to, when you buy a car, you don't have to go out and get a bank yourself. You don't have to find a lender yourself, because they all arrange that at the dealership. They will hook you up with some lender, some bank. And usually automakers have their own financing arm. uh, General Motors have their own bank called GMAC, and Chrysler has their own bank called Chrysler Financial. Hyundai has its own, bank called Hyundai, Auto Finance. Or basically, the dealership basically matches you. I mean, they arrange this loan automatically there. Um, so now our next question is, um, so if at the dealership they told you monthly payment is 500, um, then you think, oh well, I trust these guys. If you just think that they are trustworthy, uh, but still, even if they're generally good people, and there's no reason they will rip me off. Yes, they have every reason to rip you off. They have every reason. Think about it. One more dollar. I mean, one more dollar you pay is one more dollar they make, right? One less dollar uh, you pay is one less dollar that they make. So think about it. What would they prefer? Do they want to prefer uh, make you pay one less dollar or one more dollar? That goes without saying. The incentive is very clear. They say we are here for you. We'll work out a deal that's, and unless you know the math behind it, you are always at the short end, right? You're always at the short end. So you should know the math behind it. Um, so um, so if they say it's $500, then you have this taste in your mouth, unclean taste in your mouth, because everything is very questionable. Uh, am I is $500 a correct payment? Am I paying too much, or am I paying less than this is so in other words, is this a good deal or bad deal? There are two ways you can find out. Why? First of all, you might think, oh, okay, so if I'm paying $500 for the next 60 months, right, 5 years, that comes to what? 30K. Then what's the car? That's the price of the car. But you made 6K down payment, so you borrowed, the money financed, right? You financed. In other words, amount financed. Not you. Amount financed is 24. In other words, this is the principal. So you might think, oh, then 6K must be the interest. I think 6K seems, I mean, 6K seems like a reasonable interest for 5 years. If you think that way, then you are too naive, or just too naive. I mean, too naive. There's no, and why? First of all, the interest rate is 6%, right? And just by a simple calculation, right? 6% of 24K, 24,000 times 0.06 annually, at least 1,440. Then, okay, we're for 5 years, you might think, okay, then for 5 years, this times 5. Oh, that's 7,200. Wow, I should keep. I should keep this just to myself. I shouldn't let them know. I'm getting a very good deal. I'm paying less. No, no. First of all, this is still very, very naive thinking. Why? Math, even 6% of 24K is, of course, 1440, 1,440. Yeah, but think about it. Does the principal remain constant? Does the principal remain constant at 24K through 5 years? Hmm? Of course not, because you are making payments. So the principal must come down. So you cannot calculate it this way. You cannot think this way, right? So what do I have to do? So we'll have to, as I said, two things you can do is, one, two ways to find out. One, find out, because you owe 24K, which is your principal, right? Find out if the present value of all those annuities, right? And in other words, all those payments, present value of all those payments, find out if the present value of all those payments are exactly equal to 24K, the principal. That's one way, number one. Because logically, right? If this is the correct payment, then present value of all of them must be exactly equal to the principal, right? And if not, there are only two possibilities. One, this is greater or this is greater. Of course, if present value of all those payments are greater than the principal, then it's a bad deal. You're paying more than what you owe. And then if it is the other way around, if it is this, which can never happen, which will hardly happen, I wouldn't say never, will be a wonderful deal for you, because you are paying less than what you owe. I mean, if this is the case, then they are ripping you off. If this is the case, you are ripping them off. I mean, you are not actively ripping them off, but you're passively ripping them off. Anyway, that's a good deal. But that it's not likely. That's not going to happen. Of course, some people might wonder, how can that be equal to the principal? I mean, what about the interest? With the interest, shouldn't be. Look, interest is already, as I told you, this payment breaks down into what? Principal and interest. And I say breaks down into principal, partial principal, right? You remember? The LU10-3. Remember that homework problem, LU10-3? That's US rule, right? And if you each time you make partial payment, that payment breaks down into what? Principal paid back, principal to pay back, and the interest. In other words, every payment must break down into principal. So interest is already built in there. So you don't have to worry about their interest. They get their interest through payment. That's why it has to all, the present value will all have to be equal to the principal. Second method, you solve this equation, right? You solve this present value of annuity equation for payment, right? Solve the equation for payment. And this will tell you directly, you will nail the exact payment. And of course, that will be either, so that will be either greater than or less than. You can tell then the result will be, the result will be, come on, either greater than or less than 500, because that's what the dealership told you. If this is greater than 500, this is the correct payment, then this is a good deal for you because you are paying, what you're being billed for is less than what you have to pay. Or if this is the other way around, that's the proof that you're being ripped off, right? So that's more down to earth or closer to life example. So I don't think we have time to do a lot, but let's just set it up. So here I'm going to delete that's probably this one. So okay, let me clear out. So I think your the file that you downloaded from the site, from our Blackboard, should have all these as blank, right? If it is not blank, please clear them out. Clear contents. Clear contents. Clear contents. So now, let's not lose the focus. I mean, this one is our car financing example, isn't it right? Car financing example, $500, monthly, 6% for 5 years, and compounding frequency is monthly. We'll find out what the and this is our lottery example, because that's 2020. Oops, I accidentally pressed power down button. I'm hopefully okay. So I think it isn't. The power button is right above backspace button. So sometimes that's a good thing. It didn't really take it as my the computer didn't take my action as seriously. I almost accidentally ended class. So again, this is the lottery example. You won the jackpot, and if you receive, if you choose lump sum, if you choose annuity, $20,000 monthly for 30 years, right? So we can find out present value and then compare it with lump sum. We can tell which one is better option. And in this one, if the interest rate is very low, like because depending on what interest rate is, because the interest rate is called also discount rate, because when we are using interest rate to discount our cash flow, then that's called discount rate, right? So depending on what the discount rate is, the present value can be different, right? So we are almost out of time, so we're not gonna we're gonna do these examples tomorrow. We're gonna do these examples tomorrow. So I think it's time to dismiss this class. Any questions so far? Any questions? Any questions? No, no questions. All right. So then the class is dismissed.
Have a good one.
All right.
Thank you,
Take care, everyone.
Wait,
All right.
Thank you,
Professor.
Professor.
All right.
Professor.
Take care. Yeah.
When are you gonna grade the homework?
I already said at the beginning, we're gonna get it back by tonight.
Oh, okay.
I've been grading the whole weekend. We're gonna get it back
All
tonight.
right. All right.
Yeah. Okay. All righty. So stop recording. I will see you guys tomorrow. Stop recording and sign out.